Our next topic is doubly linked list. We already discussed singly linked list and circular linked list. What is doubly linked list? A doubly linked list or a two-way linked list is a linked list which contains a pointer to the next as well as previous node in the sequence. Two-way or doubly both are representing same. That is a pointer, there is a pointer which points next as well as there is a pointer which points to the previous. Three parts: data, pointer to the next node, pointer to the previous node. So, if you see this diagram, you can clearly understand. As usual, start is a special pointer which points to the first node. This doubly linked list consists of 4 nodes. One is 3, second one is 9, third one is 2 and fourth one is 7. First node, it consists of 2 pointers, next and previous. Next, which points to the next node 9. The previous, here it is null. Why it is null? Because this 3 is the first node of the doubly linked list. Definitely there will be no previous nodes, so it is null always. And second node, the next pointer points to 2, but the previous pointer points to 3. And the next node 2, whose next pointer points to 7, whose previous pointer points to 9. The last node 7, whose previous pointer points to 2, the next consists of null values because the 7 is the last node. So, in doubly linked list, the previous pointer of the first node and next pointer of the last node always null. Next, we see how to define the node of a doubly linked list. We already discussed how to define node in singly linked list and circularly linked list. Both are similar. In struct node, here there are 2 pointers. One is PREV, previous, another one is NEXT, next. So, the first part is creating a pointer to the previous node. Second one is, as usual, it is a data part, and third one creating a pointer which points to the next node. So, this is the structure definition for a node. And as usual, start initially it is null, and new node we can create with the support of dynamic memory allocation function malloc. Now, we see one by one algorithm of doubly linked list. First, we go for traversing a linked list, which is exactly same as that of traversing a singly linked list. We just start from the first node by using the start pointer and travel one by one up to the last node with the help of that while loop. And we can easily identify the last node by the condition the pointer not equal to null. So, the algorithm is exactly same as that of singly linked list. Next, inserting a node at the beginning. So, initially we have a doubly linked list with 4 elements: 3, 9, 2 and 7. Now, we are creating a new node for inserting this node as the beginning of the existing doubly linked list. So, what is the first thing we have to do? After creating a new node, we have to insert the element 8 into the data part of the new node. So, for that we are writing a statement: set new node of data equal to VAL. Next, after we are creating a node and inserting the data, what are all the things we have to do for making this new node as the beginning node? In this new node, there are 2 pointers. One is next, another one is previous. What this next pointer should point? The next pointer should point to the already existing start node. So, for that, what is the statement we can write in algorithm? New node of next is equal to start. New node of next is equal to start. What next? In new node, there is one more pointer that is called previous. The previous pointer should be null. Why? Because after you are inserting this new node, this new node is going to be act as the first node of the linked list. So for every first node of the doubly linked list whose previous pointer should be null, because there is no previous element. So what is the statement we can write? New node of previous is equal to null. Okay. What the next thing? So in the previous doubly linked list, the start node whose previous pointer is null, but after you are inserting this new node, this node will be act as the second node of the doubly linked list. So obviously the previous pointer of this start node should point to this new node. So what is the statement we can write for this? Start of previous is equal to new node. Now after we did all these things, the new node is inserted as the first node of the existing doubly linked list. But whether our task is over? No, because always the first node should be name it as start. So for that, what is the statement we can write? Start is equal to new node. Start is equal to new node. Now hereafter, the new node 8 is going to be act as a start, and all other elements of the doubly linked list is attached next to it. This is complete algorithm for inserting a node at the beginning of doubly linked list. Now we go for inserting a node at the end. So we consider an doubly linked list with 4 elements, 3, 9, 2 and 7. As usual, start is the pointer which pointing to the first node. Now we are introducing a new variable called pointer, which once again points the first node of the list by using the statement set ptr is equal to start. Why we introducing this pointer variable? Because we have to travel from the first node till the last node, then only the new node can be inserted at the end. As we discussed in the singly linked list, by using that while loop consisting of pointer is equal to pointer of next, we can move this pointer variable up to the end. Now the first node is pointing by the variable start, the last node pointing by the variable ptr, and we created a new node. Now first what we have to do, in the new node we have to insert the data. For that we are using a statement new node of data is equal to val. Now for making this new node as the last node of the existing doubly linked list, what we have to do first, already existing last node should be connected to this new node. So what is the link we have to establish? Now this pointer should be connected with this new node. What is the statement can be written for establishing this connection? Pointer of next equal to new node. Set pointer of next is equal to new node. This connection is established. What next we have to do? This new node previous pointer, this new node previous pointer should point to this ptr. So what is the statement we can write? New node of previous is equal to pointer. New node of previous is equal to pointer. Now the link is established between the already existing last node with the new node. Now the new node is connected as the last node of the existing doubly linked list. Now our new doubly linked list is with 3, 9, 2, 7 and 8 as the elements. So the complete algorithm for inserting a node at the end is here. Now we are going to discuss about the algorithm for inserting a node after the node that has value num. So it is already discussed in singly linked list. We have to identify the node whose value is num, and the new node is going to be inserted after that particular node. Now we have the original doubly linked list with 4 elements. First node is always pointed by the variable called start, and we introduce a new variable called ptr. So ptr is equal to set ptr is equal to start. So ptr is also pointing the first node. Now we have to move this ptr up to the node whose value is num by using the while loop, as similar to that of singly linked list and circularly singly linked list. By using that while loop, we can move this pointer to the respective node. Now in this example, my num is equal to what it is. You just imagine it is 9. Now we are moving this pointer up to the node whose value is 9. Now we achieve that. Now we have a new node, creating a new node. After creating a new node, what we have to do? We have to insert the value into that node. After the new node is created, what we have to do? This is ptr. We already identify this node as ptr. Then what if this 9 is ptr means, if 9 is ptr, then what is this node containing the value 2? If this is ptr, automatically what is this node? Ptr of next, because this is ptr of next. So we know the name of this node is ptr, the name of this node is ptr of next, the name of this node is new node. Now what we have to establish? First we have to establish this ptr should point to this new node. So what is the statement can we return? Ptr of next is equal to new node. What next? This new node should point to this ptr. That is, new node oda previous should point to this ptr. So what is the statement can we return? New node of previous is equal to pointer. Now these two connections established. What next? The connection between this new node and pointer of next should be established. So what is the first thing? New node order next should point to this pointer of next. So what is the statement can be written? New node of next is equal to pointer of next. What is pending here? Now this pointer of next node whose previous should point to this new node. So how we can write? This node is pointer of next. What is this place? Pointer of next order previous. So how we can write? Pointer of next of previous. Pointer order next order previous. இது எதை point பண்ணும்? Which should point to new node point பண்ணும். So what is the statement we can write? Pointer of next of previous equal to new node. Now these four connections, once these four connections established, which means that the new node is inserted between 9 and 2. So our final doubly linked list is looking like this. The complete algorithm for inserting a node after a given node is given here. Now we see the algorithm for deletions. In that, first one is deleting the first node. Now we have the doubly linked list with 4 elements, 3, 9, 2 and 7. As usual, start pointing to the first node of the doubly linked list, and we introduce a new variable called pointer, which once again points the first node by using the statement set ptr is equal to start. Now if I want to delete this first node, what I have to do? We have to identify the second node. Now this node is start, means what is this node? Start of next. Okay. Now what is the statement can make? This node is going to be act as a start. Now start is equal to start of next, because start of next அப்படிங்கிறது இப்போ 9 represent பண்ணுது. அப்போ start is equal to start of next அப்படின்னா what is the meaning? Now this 9 is going to be act as the start அப்படின்னு அர்த்தம். Start is equal to start of next. Now this become start hereafter. Now the first node is named pointer, second node which is named start. If this is going to be act as the first node of the new doubly linked list, whose previous should be null. It should not point to anything. How we can do this? Start of previous is equal to null. Start of previous is equal to null. Now this is our new doubly linked list. Here we have to do one more thing, that is we have to release the already allocating memory for this pointer. So what is the statement we can write? Free of pointer, that is it is going to be deallocate this memory. Now this is my new doubly linked list 9, 2 and 7. The complete algorithm for this deleting the first node is given here. Now we are going to see the algorithm for deleting the last node. As usual, the first node which is pointing by the variable pointer variable start, introducing a new variable called ptr which is once again pointing to the first node. So for achieving this we are writing set ptr is equal to start. Now we are moving this ptr to the end of the doubly linked list. Why we are moving this pointer to the last node? Because we are going to delete the last node, the node which is just prior to this last node, whose next should be null. Then only the list will be end here. If the last node is ptr, what is the name for this node? ptr oda previous அப்படினு சொல்லலாம். But whereas in singly linked list, if I want to give the name for this particular node, we are using a variable called pre-ptr. Biggest difference between singly linked list and doubly linked list. We never use a variable called pre-ptr in doubly linked list because already there is a pointer from existing node to the previous node. So if this is ptr, automatically what is the name for this node? ptr oda previous. If this node is ptr oda previous அப்படினா what is this? ptr oda previous இந்த node அதனோட next. So அப்ப ptr oda previous oda next தான் இந்த part. இப்போ அது what we have to do? It should be null. So what is the statement we can write? ptr oda previous oda next equal to null அப்படினு போட்டா automatically this part will become null. Automatically the list will be over here. Now this is end of list. Now what we have to do? We have to release the memory of this variable ptr. So for that we just write a statement free ptr. So this is the deleting the last node. So this is the complete algorithm for deleting the last node of the doubly linked list. So the last and final algorithm of doubly linked list is deleting the node whose value is num. In singly linked list and circularly single linked list நம்ம என்ன மாதிரி deletion பார்த்தோம்னா NUM க்கு அடுத்ததா இருக்கிற நோட delete பண்றதுக்கான அல்காரிதத்தை பார்த்தோம். இங்க ஒரு சேஞ்சுக்கு நாம என்ன பார்க்கறோம்னா deleting a node whose value is num. எந்த நோடோட வேல்யூ num அப்படினு இருக்கோ அதை delete பண்ணுங்கிறதுக்கு அல்காரிதம் பார்க்கறோம். ஏனா இந்த கேஸ்ல வந்து மூணு விஷயங்கள் இருக்கு. One is deleting a node whose value is num அல்லது deleting a prior to the node whose value is num அல்லது deleting a node which is next to the value which is num. அதாவது என்னன்னா இப்போ ஃபார் எக்ஸாம்பிள் NUM வந்து 2 ன்னு வெச்சுக்கோங்க. இதுல நான் இந்த 2ங்கற நோட delete பண்ணலாம் அல்லது 2க்கு முன்னாடி இருக்கிற நோட delete பண்ணலாம் அல்லது 2க்கு அடுத்ததா இருக்கிற நோட delete பண்ணலாம். இதுல மூணு வேரியேஷன்ஸ் இருக்கு. In examination they may ask anything. Generally கேக்கும்போது you can write any one of these three, but specific according to the question you have to write the algorithm. It's just slight modification அவ்வளவுதான். இப்போ நான் இந்த எக்ஸாம்பிள் என்ன பண்ண போறேன்னா NUM எதை ரெப்ரசன்ட் பண்ணுதோ அந்த நோட delete பண்றதுக்காக we are going to see. Now in this example I just imagine this is NUM, that is NUM equal to 2. In this example I just imagine it is 2. So in the existing doubly linked list, initially the first node is pointing by the start, and by using the statement set pointer is equal to start, once again the ptr is also pointing to the first node. Now what is the next target? We have to move this pointer up to the node whose value is 2, that is this one. So for that we are going to use the while loop. which is also very similar to that of singly linked list and circularly singly linked list. So after executing that while statement, this particular node is going to be, name it as pointer. If I want to delete this, what is the thing we have to do? This 9 should point to this 7 instead of this 2. That is, this link should be established. It should bypass this value 2. If this node is PTR, what is this node? PTR oda previous. What is this node? PTR oda next. Now you just establish this link. This is PTR oda previous. What is this place? PTR oda previous oda next அப்படினு சொல்லலாமா? So PTR oda previous oda next equal to what? It should be this. What is this? PTR oda next. So what is the statement we have to write? PTR oda previous அப்படிங்கிறது இந்த நோடு, அதனோட next அப்படிங்கிறது இந்த place. இது எதை பாயிண்ட் பண்ணணும்? இதை பாயிண்ட் பண்ணணும். இது ஆக்சுவலாக என்ன? PTR ஓட next அப்படின்னு சொல்லலாம். ஸோ PTR ஓட next. ஸோ set PTR ஓட previous ஓட next is equal to PTR ஓட next. இதை பிளைண்டாக if you are not understanding and you just mug up பண்ணிங்கன்னா highly difficult to remember during examination. That's why I explained with the support of this diagrammatic representation. I think you clearly understand now. So okay, whether this link is enough for completing this task? No. What next? இந்த 7 அப்படின்னு இருக்கு இல்லையா, இந்த நோடோட ப்ரீவியஸ் இப்போ எதை பாயிண்ட் பண்ணும்? ஆல்ரெடி இந்த 2 பாயிண்ட் பண்ணிட்டு இருக்கு. நவ் ஹியர் ஆஃப்டர் திஸ் பாயிண்டர் ஷுட் பாயிண்ட் டு பைபாஸ் பண்ணி எதை பாயிண்ட் பண்ணணும்? இதை பாயிண்ட் பண்ணணும். அப்போ இதை பாயிண்ட் பண்ணணும்னா எப்படி ஸ்டேட்மெண்ட் எழுதலாம்? இப்போ இந்த பிளேஸுக்கு என்ன பேர் கொடுக்கலாம்? இப்போ இது திஸ் இஸ் பாயிண்டரோட நெக்ஸ்ட். இந்த நோடு வந்து பாயிண்டரோட நெக்ஸ்ட்டு. அப்போ இது என்னது? பாயிண்டரோட நெக்ஸ்ட்டோட ப்ரீவியஸ் அப்படின்னு சொல்லலாமா? இந்த பிளேஸை பாயிண்டரோட நெக்ஸ்ட்டோட ப்ரீவியஸ். இப்போ இது எதை பாயிண்ட் பண்ணணும்? இட் ஷுட் பாயிண்ட் டு இந்த நோடு. இந்த நோடுக்கு பேர் என்ன? பாயிண்டரோட ப்ரீவியஸ். ஸோ அப்போ வாட் இஸ் த ஸ்டேட்மெண்ட் கேன் பி ரிட்டர்ன்? பாயிண்டரோட, இது பாயிண்டரோட நெக்ஸ்ட்டு. பாயிண்டரோட நெக்ஸ்ட்டுங்கிறது எது? இது. அதனோட ப்ரீவியஸுங்கிறது இது. which should point to this what? Pointer previous. Now the two links are established, so this 2 is bypassed. This memory should be deallocated. இதை deallocate பண்ணனும்னா by using the statement free of pointer. The complete algorithm for this is given here. So now this is the small comparison between singly linked list algorithm and doubly linked list algorithm. Now for inserting a node at the end in singly linked list, this is the algorithm which was we already discussed in the previous classes. And similarly for inserting a node at the end in doubly linked list, the algorithm, there is only one new statement is added, that is new node of previous is equal to pointer. Similarly for deleting a node at the end, our singly linked list algorithm is here. And whereas for deleting the node at the end in doubly linked list, once again there is only one new statement is added, that is set pointer of previous of next is equal to null. As I already said, if you study singly linked list algorithm thoroughly, you don't bother about circular singly linked list and doubly linked list. For the entire 4 types, singly linked list, circular singly linked list, doubly linked list, circular doubly linked list, base is singly linked list. If you once good in singly linked list algorithm and coding, you no need to bother about the remaining 3.